Hey, what's up everybody? It's Andy from CleanSwifter.com and I'm back to show you another refactoring from Martin Fowler's book, Refactoring, Improving the Design of Existing Code. The book is like a recipe book of refactorings and all stuff that you can do that when you're working with a project, different tweaks you can make to your code base to improve the maintainability of that code and ultimately get it to that point of cleanliness that we're looking to achieve and everything I write about on CleanSwifter.com. This week, the refactoring we're looking at is called Extract Class. Extract Class is kind of like one of the most essential refactorings that I think of when I'm thinking about what is a refactoring. Oftentimes, in object-oriented programming, you're working with classes, and classes that represent really anything, but oftentimes kind of like a model representation of whatever business unit that you're building within your app. These things will grow over time. They'll accumulate newer properties you'll add to them. You'll get new behaviors on them. And eventually, you'll identify that there could be pieces within that class that you could then extract into something new, that it stands alone by itself. Think about, in the example we're going to look at, I have a person struct, a value type in Swift, and in that person there's going to be a person has a name, but their name is going to be made up of a first name, a middle name, a last name, optionally a suffix, and people have addresses, and addresses are made up of a street, a city, a zip code, a country. And you know, when you're starting off in your system, you may have thought to model each of those attributes on the person itself as strings, but instead really what you can do is then look at those objects, look at each one of those attributes and realize that maybe an address is a thing by itself. Maybe the name is a thing by itself. So let's take that group of properties, extract it into its own thing, and then compose that new thing in the person object itself. Because of that, you can then down the road find new uses to reuse those new objects in different ways that then don't rely on the person. Maybe the address can be assigned to an item, or a name can be assigned to a pet, a dog, something other than a person. And you can then find reuses for those classes. That's really the value of where Extract Class comes into play. Now again, all the videos on CleanSwifter.com, it's all about learning Swift, and right now Swift 3 is brand new on the scene, and that's where I'm going to show you this refactoring and all the past refactorings from Martin Fowler's book. This is going to be in Swift 3, so just in line with Swift 3, we want to be using our value types as much as possible. So I'm going to show you these refactorings in the context of a struct. But remember, Martin Fowler's original book was back in the days when object-oriented programming was a lot hotter, and you know, he talks about his extract class, but it can be it can apply just as easily to classes or structs. So let's take a look at extract method using a struct in Swift 3. All right, here's our person struct. This is much more simpler code than if you've seen any of the other refactorings so far on CleanSwifter.com from Martin Fowler's book. And like I was just saying, in a person, this could be a model representation of a person in your app. And a person, well, they have a name. And their name could be made up of 3 different strings: a first name, a middle name, and a last name. And likewise, people have addresses. They live somewhere. And addresses are made up of streets, cities, state, zip code, and country. So this could work perfectly fine. But again, you might find, you know, reasons due to maintenance or purely self-interest that you want to make this code a little bit cleaner. And optionally, you know, you might find needs that'll surface to reuse the classes that you're creating. So to extract class, or in this case struct, first thing we're going to do is let's extract a new name struct. So to do that, I'm going to create that new struct name. And from there, I can then rip out these 3 name strings, put them in the name struct, and instead replace those 3 original strings with the new value type composed within person. This is functionally equivalent code, and instead I'm actually masking the underlying implementation of name inside a person. Now, of course, you can then poke through name and see that it's 3 strings, but you could optionally encapsulate these even further by making by, for instance, making these variables private. Instead, it can a designated initializer that takes in certain number of strings to construct a name, or you can add behavior onto name to format the name, or in things like that. So now we can do the same thing with address. So I can create a new struct for address, and just like before, I'm going to take all 3 strings from person, put those on address, and now compose a new property in person of type optional address and reference my new struct. So right there, that is extract class. I've taken classes from person, I've taken some attributes on person and extract those into new structs. And now we have this code that can be used elsewhere within our app and provide that much more utility for identifying things with addresses or names. And now person also is much more clean. So there you have it. Extract class is that easy. Now the thing is, you might be wondering, okay, well really what's the utility in that? Again, it's look for those places where you don't want to duplicate code. So if you find, one first smell that you could identify where you want to use extract class is if all of a sudden you're duplicating logic that makes up a thing in 2 places. So imagine you just saw there's a person object with a name, or a person object with an address. Well, like I mentioned before, your pet has a name. Whether it's your dog, cat, bunny, guinea pig, whatever. A pet has a name. Now, you don't want to be repeating strings within your pet and person, and yes, pets can have a first name, last name, and middle name. Mine does. And instead, rather than duplicating code that represents implementation of a name in 2 places, you can then instead extract that name into its own value type, struct or class if you need to, and then reference that from both places, the pet and the person. So that's the extract class refactoring. You know, to me, another thing is back in the good old Java days, before I was coding iPhone apps and using a different IDE, extract class was actually one of the IDE provided tools of refactorings that it could provide. So I could literally in the IDE highlight a piece of code, right click and say refactor extract class. Xcode for Objective-C provides something similar, and I'm really waiting for the days when refactoring support is back in Xcode for Swift. Because I think that will finally mark when like Apple recognizes Swift as a truly first-class citizen next to Objective-C. I think you'll even find in Xcode today that there are some refactoring tools available, but if you try to use it on Swift code, it'll tell you that Xcode doesn't support it for Swift code. So I hope you enjoyed this video that demonstrated the extract method refactoring in Swift. Again, this is another video in my series each week covering a different refactoring from Martin Fowler's book, Refactoring, Improving the Design of Existing Code. You can buy the book in my Amazon affiliate link in the description for this video. That helps support cleanswifter.com. I hope you check back next week for its refactoring. And in the meantime, happy cleaning.